everybody. I've had a few people ask me lately just about how to track a real estate or a property loan and how to sort of analyse things like coming off a fixed interest rate, what happens when you go back to variable, and how that affects your loan, and how you can analyse it. So fortunately, Excel's really I guess handy and quite quick really to do some sort of analysis. So what I thought I'd do is I'd quickly show you this. I guess a quick spreadsheet that I've put together, which might be of interest, and more than happy to maybe at the end I'll run through really quickly how to actually build it if you're interested. So what we can do is basically we start off by looking at this left-hand side over here. We can put in the interest rate. So what I've set up here is a base and a comparison. So what we can do is we can look at our base scenario, which might be sort of what our plan is for the loan. And then here we can test some different scenarios. Let's say, for example, we're on a fixed interest rate and we're going to be coming off that into variable. You could actually compare what that's going to do to your loan and so forth. So, and I've also put together a quick little chart that we can look at in a second to compare the two different loans. So all we need to do is, obviously, we'll start with both being exactly the same. So we just set up the interest rate, the annual interest rate, which I've just for here assumed is 5%. And then put in here the actual loan amount, which just for this example, we've used 450,000 as a negative number. Now, what I've done here is because I think almost all loans, vast majority at least, are in monthly payments or monthly terms. Sorry, monthly payments. Like interest is charged or calculated monthly. So I've assumed here it's a 10-year loan. So basically, to work out the months left, we basically multiply 10 by 12 to give us how many months of the loan, which is 10 times 12 is 120 months for 10 years. And then what we can do here is use this little formula called PMT. Now, if I go into here, you'll see a bit clearer. So what it does, it's quite clever, is you put in here, first of all, the interest rate. So here you can see I've divided the interest rate, which we've got in C6, by 12, and that's because it's we don't want an annual rate, we want a monthly rate. And then here we have the basically the number of payments for the loan. So we've already calculated that. That's in months again because it's a monthly, calculated monthly. So that's the 120 from C8. And then down here we have the present value, which is effectively the amount that the loan is now. And then the future value, obviously we need it to be 0 because we're paying out the loan over those 120 months of period. So when we do that formula, what it does, it actually gives us the amount that the bank would I guess charge us monthly, which obviously includes an interest and a principal component that would need to pay off that loan in 10 years at that 5% interest rate. So, and down here, obviously, total payments will just simply be the number of months, 120 in this case, times the total payments. That gives us the total amount that we've actually paid. So to pay back the $450,000 loan, we've actually had to pay $572,000. Now, the interest is really just the difference between the two, because obviously the interest is just the extra amount that we've had to pay for the enjoyment of having the loan. So basically, it's just we can see here one plus the other because it's minus, and that then gives us the interest that we paid for the loan. And what I've done here is I've summed up from here. So in fact, we'll come back to this in a second. So that really is the crux of a really fast way of working out. And so let's just say, for example, we can quickly work out, well, what if the interest rate is now going to, say, 6.5%? So sorry, I've done that as a comma, not a decimal point. So if interest rates, say, for example, are fixed at 5, coming off to 6.5, you can see our monthly payment's going to go up sort of in the order of $400. And you can see it quite significantly impacts how much more we actually need to pay towards paying the loan off. So it's an extra, sort of $40,000 that we actually need to pay off that with that 1.5% interest rate rise. So you can see very quickly you can start to play with different scenarios. Say worst case scenario, interest rates go to 10%. All of a sudden we're paying, significantly more, paying, $1,200 more a month now. But what's probably more scary is the fact that we're paying, a lot more over the period of the loan to pay it off. So a really quick little way of comparing different things. So I'll put that back to 5% for just now. Now, also had one of my friends actually ask me about, well, what happens if I make extra payments to the loan and so forth, and how do I test different things? Because the interest rate obviously won't be fixed at 5%. You know, I'm unlikely to have got a 5% fixed loan for 10 years. That's just not really possible. So what's going to happen is that over time the interest rate will change, and there'll be different things happening. So the way I like to do it is I've set up a base scenario, which is this one here. So effectively all I'm doing is just putting in the loan start amount and then the interest amount here. And then all I'm doing is copying across the total payment amount from our calculations here that we know we need to pay it off within 10 years. So according to that, by the end of 2022, 32, we would have paid off the loan. You can see here the calculations are showing that we've paid off the loan in that 10-year period. So that's the total payment there to get us to that zero. Now, the interest on the loan is obviously really important. So all I've done here is worked out the total, multiplied the total loan by the interest, but divided by 12 because obviously it's calculated monthly, and that then gives us the actual monthly interest amount, the interest payment amount. Then here, all we're doing really is the total payment. Well, the way I've worked it actually is the interest minus, because of the plus and minuses, the total payment, and that gives us that gives us the principal amount of the actual principal component of the loan payment. So all we're doing here really is just taking the original loan, taking away the principal payment, or in this case, because it's minus, we're adding the principal component of the loan payment, which then gives us the new loan total. So we paid $4,700, but we actually only paid off $2,897 off our loan. So that then works out the loan at the end of that period. Now, in the next month here, so in February, all we're doing really is copying the amount from here. Now, I'll come back to this in a second. This is just some if statements, which you'll see in our actual calculations can become important. But for now, all we're really doing is just copying that amount down there and then doing exactly the same thing. The payment is just from above. The interest obviously reduces because the total amount of the loan has reduced. So we're multiplying by the loan start amount by the 5%, but because it's lower, we pay less interest. And therefore the principal amount we're paying off the loan is actually larger. So therefore our loan continues to reduce. So, and so on is how it goes. So you can see that's a really quick way of visualizing the loan amount. So over here on chart 1, the orange line's actually hidden behind the comparison, but the line effectively goes from our 450, and you can see the profile of how we paid off to get the loan balance back to zero. Okay, so next up, what we can do is have a look at the actuals. So the way I try and look at it is I have my base scenario, which is pretty much what I said at the start of the loan, and this is what I'm hoping to achieve over the course of the loan. And then what I do is then I'll have this actual, which is basically a replication of this left-hand side of actually what actually happens. So let's say, for example, that I say, well, look, I can afford to pay an extra $1,000 a month off my loan, so I can put in $1,000 here. And then straight away you can see the effect it has on the loan. So over here we can see what it's done is, now this section here, sorry, the top section here, just to be clear, is basically just really only comparing, the calculations are all self-contained within this little section. So really all it's doing is looking at this 5% or the changes to the time of the loan or the interest rate, whereas this section down here is actually summing, if you look at the formula, is effectively just summing the columns here in these calculations. So if we pay an extra $1,000 a month, you can see in the base scenario, we're paying total payments of $572,000. And a comparison here, we're actually paying less, well, almost $30,000 less, because we're actually paying the loan off earlier. Now if we go back to chart 1, you can see very clearly that in our base case, obviously, is obviously taking us 10 years to pay it off, but now because we're paying a little bit extra, or $1,000 extra, you can see a lot more rapidly. The profile is a lot steeper, and you can see we're really paying it off sort of 18 months early there, which is really good. So you can play around here with different things. So all this really is very, very similar, and there's a few little if statements in here too, because obviously if we pay extra, we want to make sure that when we come down here, that the loan actually zeroes itself out, so that way all of our calculations are more accurate. So, and what's really good too here, so the way I do it for my loans is I actually enter the actual amounts in here. So I overwrite the formulas as I go through, because obviously this is based on a 30-day month for the interest calculation. So it's based on just every month having the same number of days. So you will find when you look at your loan statements that the actual interest payments will be slightly different just because of the days of the month aren't all the same. So what I generally do is actually on this right hand section, I actually make this replicate my actual bank account or my loan account numbers. So that way I've got a sort of what I had hoped to do and then what actually happened. So all we can do is basically just overwrite things. And from time to time I do make extra payments, although I'm currently on fixed interest rate loans, which are actually expiring soon, which is what prompted me to have a look at this. But I think with the bank I'm with, you can make $10,000 extra $10,000 extra payments a year without being penalised. So if I ever make those payments, I can obviously put them in here and just overwrite the formulas. But the way it's set up now is more for testing. So it's very similar to the left-hand side, but I'll just talk through some of these if statements which are needed. So the first row really is pretty straightforward. Now, this formula here is what's important is basically what it's saying is that if the loan so actually, we'll do it on the second row, which is probably more important. Actually, it's got all of the if statements in there. So what happens here is basically it's saying that if my loan is actually zero, well then my loan make sure it's zero, because otherwise you can end up with some problems with it sort of becoming a positive loan, which then stuffs up your calculation. So all I'm doing here is just saying, look, if the loan is if that amount is basically greater than zero, so the loan's been paid off, just make it zero. And then what happens here is basically what I do is I check to see if my monthly payment is bigger than the amount of my loan, then just pay off the amount of my loan. So all I'm doing is that if this amount here is bigger than the loan amount, then just make it the loan amount. If not, make it my normal payment per month. So that way too, if this amount that's left is less than my total payment I need to make, it will just make it equal to that amount. Again, what I've done here is I've said that, look, if the loan is zero, then just make the interest payment zero for that month, because otherwise it will, even if it's a small amount, I assume that I'm paying it off that month and therefore not paying interest. So basically all it's doing is saying here that if the amount that needs to be paid is equal to my starting loan amount, that means that I'm paying it off in that month, therefore make the interest zero. If not, just do the total loan times the interest rate divided by 12 as we had over there. And then the principal is that formula doesn't change. And then the extra payment, what I do is, because I actually copy it from above, I'm just saying that if the loan is zero, then stop paying the extra amount, because obviously we don't need to, because I paid the loan out. So that way too, when I type in $100, you see it just fills all the way down. But when you get down to here, you'll see what it's doing is it's basically saying that because I paid the loan out, that I don't need to make extra payments. That way too, when I add up all of my numbers, I don't need to make any changes to it. And then the rest of it really is exactly the same as we explained on this right hand side. So it means we can play with, let's say for example that our interest rate jumps up to 6%. You can see how I've made it so it just copies it down below. And then let's say I'm making an extra $1,000 a month. Actually, let's do it the other way. Let's say we get a really good rate at 4.5%. Then we can start to look at the impact that has on our loan payments over there. Pretty straightforward, and it's a really simple spreadsheet, but I find it really useful to track my actual loan payments, and I can test some scenarios and different things on this side. And then on the left here, I've got my sort of baseline baseline loan payment, so I can see sort of if I'm tracking above or below what I'd originally hope to do. So I hope that's helpful, and look, if you've got any questions or want me to go back and explain anything in more detail, more than happy to do that. But I hope you find the video useful, if not helpful, and enjoyable, hopefully. But yeah, let me know if you've got any questions, and hope you all have a great day. Thanks all. Bye.